you in finding out the solution, right? नीरज जी, we can record after शुरू होने के बाद में कर देंगे. Welcome today's faculty, Dr. A.K. Sinha, who is Senior Principal Scientist, Geotechnical Engineering Division, Central Road Research Institute, Faridabad, right? And sir will be covering the hydraulic design of road drainage. Very good morning and welcome you, sir, personally as well as on behalf of IHE, and it is over to you for making your presentation, sir. Have a great day, friends. I will not be there in concluding session. Thank you very much for attending in large number. I also take this opportunity to thank all the implementing agencies for sparing their officers for attending this very important training program. Thank you very much once again. Thank you. Over to you, sir. Thank you.
Thank you, Dr. Sanjay ji. I am able to be able?
Yes, sir. You are audible, sir.
Okay. So I'm meeting all welcome to all participants and I'm meeting this is the very big training program on only for drainage, which is very important for road users. So I'm meeting already topics has been covered largely because already 5 days is over. So this is the our session is last one, one of the. So in this presentation, I will cover drainage aspect regarding the road construction and one interesting topic, airport drainage system, a case study. Also, I will include in the presentation in the ending session. So now I like to start the presentation.
You are welcome, sir. I also request if it is possible for you to have a case study of any road or highways, including structure, and that you can also share if you are able to, sir. Thank you very much, sir. Thank you.
Thank you, sir. Thank you.
Thank you very much.
Presentation is coming?
Yes, sir. Screen is visible.
Now it is okay?
There is something extra window is there that you can just close down, sir. Okay, now you can have a slideshow, sir.
Now it is okay?
Yes, sir. Excellent, sir.
Okay. So, good morning to everybody, participants. So I will cover here drainage aspect on that for road construction. So if you will see, drainage is very important for road construction. Adequate drainage is primarily requirement for road construction. Which will ascertain the structural behavior of the roads and functional behavior also on the road if drainage aspect is covered fully. So you will see pavement structure including subgrade and other layers must be protected from ingress and quick disposal of water from the pavement. Otherwise, over a period of time, subgrade will saturate and distress will be occurred on the pavement structures. That is why rapid disposal of water from the pavement and subgrade is our basic requirement for road design, for proper road design. So if you will see, total cost of the drainage relative to the construction of total construction of the roads is about only 2%, but we are neglecting this, which is reducing the life of pavement regarding the structural and foundation design of roads. Damage due to inadequate drainage is largely categorized in three categories due to overtopping of road by flood water, erosion of shoulders, embankment slopes due to runoff directly coming on the embankment slopes, weakening of the pavement structures and subgrade through overflow or ingress of water into the pavement or seepage of water into the pavement. Remedy lies in providing proper pre-board above the highest flood level to overcome the overtopping problem of water. Road is not overtopped, so we have to ensure the by the construction of HFL, it should be more than HFL. So overtopping problem will be sorted out and cross slope camber drainage system for quick disposal should be provided to dissipate the runoff water, surface runoff water, and also proper subsurface drainage should be provided. What is the advantage of good drainage? We will see for proper performance of highways for a long duration. Good drainage is required. It will reduce the maintenance costs and ultimately riding quality for the long duration of the payment will be available for pedestrian and vehicular. For design of drainage system, before designing of drainage system, we have to keep these all parameters in the mind. Expected traffic, what is the expected traffic, importance and configuration of the single road or double lane road or new road, or it is widening of existing roads. Drainage catchment areas nearby the alignment of road, existing drainage system, we should consider before the design of drainage system, geological parameters, hydrological parameters, hydrogeological condition of the road and around the proposed alignment or along the roads, geometric characteristic of the roads like alignment, road profile, area of extreme gradients or cross slopes, area of excavation and landfill area, any limitations in and around highway which may affect the design of drainage systems. And lastly, we have to see which type of people are living like farmer or their occupations, localities, alignment of the roads can have a vital bearing on the problem of drainage system. In case of new roads, surface drainage should be one of the criteria for fixing the alignment. For example, locations parallel to large streams and running close to them are likely to give rise to constant travel, besides the fact that several converging tributaries, distributaries would be needed to be crossed. For an ideal alignment, wide, steep, heavy cuts or fills, as this situation have problem of drainage and erosion, Problems of these types of are often faced in rolling terrain, since there is a alternate cuts and hills. Unless designed with an eye on the smooth disposal of surface water, it may place havoc with the natural drainage of the area and give rise, among other difficulties, to subterranean flow under the crosshead. These are the information should be collected before designing of drainage system, longitudinal drains, ditches along the road, collect the surface runoff from the road surface and adjoining areas for a smooth disposal of flow to nearby streams, rivers, nalas, or depression or ponds through cross drainage works. Longitudinal roadside drain originates at a reach point of natural ground along the proposed alignment of road and ends at a predetermined outfall, that is maybe culvert or existing stream or sometimes diverted through excavated channel. Designer of road drainage system must be familiar with the terrain of this area through which the road is passing, properties of soil, subsoil, and cover conditions. Natural drainage system prevailing before the road construction, rivers and its tributaries, draining the area, ponds, and other water bodies. We have to collect information regarding the topography of the area, hydrological or hydraulic condition, topographic features like habitats, industries, marketing places, institutional buildings, existing roads, food tracks, cable lines, gas electricals, telephone lines, railways lines. Before designing of drainage system, we have to collect this type of information. Details of existing drainage, canals, marshy lands, waterlogged and flooded areas, forest areas, agriculture areas, rural and built up areas, information we have to collect like this. Rainfall and runoff, high water marks, including photographs, videos at the site. Most of these information are available in the relevant updated topo sheets of the area. Otherwise, remote sensing data from the satellite imagery, drones, etc. should be taken from that. Site visit by the drainage engineer is necessary. He can collect many of the vital information needed for the design of drainage system from the field. Interacting with local people also, panchayats, district authorities, central and state government organization who may be already in possession of similar data, which will be helpful for design of drainage system. Regarding drainage system, there are several IRC codes have been published, like IRCSP 42, which deals with guidelines of road drainage, IRCSP 50, urban drainage system, IRCSP 48, drainage on hilly roads, IRC 34, drainage in hilly terrain, and IRC 37, use of geotextile flexible pavement. And last one is IRCSP 59, ground improvement by reinforced flexible pavement. These are the IRC guidelines which deals with the drainage in different conditions. Hydrological design involves computation of design flow through the drain. Hydraulic design of drain section is necessary to ensure that the capacity of drain is sufficient to convey the design flow to the outlet points or culvert or cross drainage structures. When the road runs along the ridge or watershed lines, the cost of road embankment and the drainage works is the least. Unlike a canal, however, a road has to connect rural and urban areas, and it may not be always possible to align it along the ridge lines all along the road. No drainage needed in ridges where road runs along the ridge or watershed. On the ridge itself is higher level. So in that situation, drain is not required. In that situation, water will be drained. In hilly and sub-hilly terrains, intercepting drains are required only along the foot of the hills. In areas where the road is in hill cut, drains are needed on both sides of the roads. Later on, we will discuss in details as a surface drainage and subsurface drainage. In case where cutting is involved, meticulously care is needed right at the start to anticipate the volume of water flow so that necessary design measures can be adopted to avoid instability of the road. Surface drainage is just one among many other considerations in road location, but it warrants careful attention. Normally in plain areas, road surface elevation in full sections is so fixed that the top of the subgrade shall be at least 0.5 meter above the original ground level. In flood area, the bottom of the subgrade shall be 1 meter above the highest flood level, and highest flood level should be decided by the intelligent inspections, local observation, inquiries, and studying the past records available in the PW department or RU department. Where it is not possible to assess the highest flood level, it shall not be lower than the general ground level. As per IRCS 57, allows top of the subgrade at 0.5 meter from the ground level. Properly, runoff should be estimated before design of drainage system. Sources of runoff are generally from rainfall and snowfall. So runoff is rainfall minus losses due to infiltration, permeability, all those things. Runoff governed by the rainfall factors and basin factors, and losses due to interception, percolation, evaporation, evaporation transmission, and storage. Rainfall in India, a station and mean rainfall discontinuous or continuous rain gauges should be measured from that. Snowfall in India, intensity, duration, frequency depends. Measurement of runoff, estimation of runoff stream gauge or hydrograph. If a consolidated view is taken, there are three aspects of surface drainage design in which the road engineers should particularly interested. The first concern is the fast dispersal of precipitation, rainfall on the road surface so as to minimize danger to moving vehicles by proper geometric design of the road, shoulders and verges by providing requisite camber and longitudinal gradient. Second requirement is water from the road and the surrounding area should be successfully intercepted and laid away to natural outfalls by a system of suitable surface dams. Shallow ditches by the side of road or catch water drains on the hill slope. In third, we can say the engineer must build adequate cross drainage structures at river crossings and minor streams by providing bridges and adequate number of culverts so that there is no flow of obstruction. Before designing of drainage system, we have to do survey and investigation. For that, we have to prepare the alignment plan, longitudinal and cross sections, and contour map of the area. Hydrological survey, such as rainfall analysis and runoff, high flood statistical information for the region, particular region where we are going to design drainage system and hydrologic and hydraulic design. Recourse to remove remote sensing methods such as aerial photography, satellite remote sensing may have to be made if necessary facilities are available. Factors which may have a bearing on road drainage such as rainfall, topography, and natural drainage of the area, crossfall or longitudinal profile, existing drains and cross drainage works, and the internal drainage of the pavement layers should be recorded. Preparation of inventory of existing bridges, culverts, or natural causeways. Additional culvert requirement and their location based on site inspection, preferably during rainfall season or from local information. What will be the effect if proper drainage system is not implemented along the road? So these are the hero effect of not properly drainage system is implemented at the site. So erosion of slope of the embankments may occur valley or hillside due to surface or subsurface water. This will also reduce the strength, slope strength. It will increase the subgrade, subbase moisture, which will result in the failure of flexible or rigid pavements, damage due to cross sections. It will decrease the pavement life like rutting or fatigue. It will increase the cost of maintenance. A skid resistance of the wet pavement will be less, which may result as a accident of vehicles. Now we will show you some of the failures of roads due to ineffective or improper drainage system provided along the roads. This is the surface water on road, which can lead to hydroplaning, or we can say skidding of the vehicles. This is the uh, water, surface water present on the pavement. It may lead to the skid of vehicles. which will lead to accident. Another one is damage of road surface due to ineffective drainage in hilly terrain. Both are the case. We will see how due to improper drainage system provided along the hilly roads. Another one this is the gully on the embankments. Another one is earthen shoulders on concrete road almost eroded due to surface runoff. Another view of the erosion of the embankment slopes on flexible pavement roads. Another view of the poorly maintenance of the slope due to that long, or you can say tall grass are present, which is prohibiting the flow of water from the embankment slope, which leads to a stagnant of water on the pavement and consequently leads to tornado accident. See another view of the concrete block shoulders. Here earthen shoulders of flexible pavements are fully neglected and there is no any provision of drainage system is provided and the road is getting damaged. This is the potholes created. Another one view of that poorly drainage system provided. This is another view of the improper drainage. Example of that, fully road is damaged and potholes and ponding of water is present on the roads. Another due to ingress of water, subgrade damaged and which is percolated up to the top of the bituminous road. So flexible pavement failures due to improper drainage, we can say it may be due to accumulation of water on the pavement surface. A stripping of bitumen from the aggregate results in breaking up of pavement and under the heavy loads, decrease in interface bond between the bituminous binder force and WPM base force. Heavy wheel loads would increase water pressure, which can cause erosion and ejection of materials of pavement layers, loss of the structural strength, and deflection of subgrade base and subbase layers results in cracking or generation of potholes. Free water contributes to oxidation or loss of flexibility on the rigid pavement failure due to improper drainage, violent displacement of granular materials through joints during wheel movement across the joints, loss of support and cracking of free pavements. In the later slides, we will discuss the mechanism of failure of flexible pavement and rigid pavement. So we will see mechanism of flexible pavements. This is a pavement without traffic, and this is the position of same pavement with the traffic load. You will see through wires water will be percolated in this, and during the movement of vehicles, pore water pressure, or we can say hydraulic pressure, hydrostatic pressure will be developed, which will uh, force to force to force water to dissipate the materials, separate materials and other materials, and which leads to failure of pavements. In the rigid pavements, this is the section of rigid pavements uh, where construction joint is there. When traffic is moving on the rigid pavements, through the construction joint, water will enter and water pressure will be generated. And here, if you can see, violently from the construction joint or weak joint, we can say, water along with materials, aggregate materials, violently will be coming from the joints. So, and then which leads to failure of rigid pavement. If you will see how pavement is affected through water percolation. You will see water may percolate through the fats present on the bituminous layers. It may be saturated through capillary from the groundwater, and it subgrade may be saturated through water coming from the through seepage or through permeability from the high ground, and after saturation of the subgrade, pavement may be failure may be occurred in the pavement. So you will see infiltration of water through pavement either through cracks or joints in rigid pavement, and in flexible pavement through cracks may come through infiltration of water from the top. Amount of water entering in the bit surface depends on its density and voids. So how much water coming from the top, it's depend on the density of the bituminous layers and voids present in the bituminous layers. Seepage from high ground, seepage from the high ground, also water will come from the high ground and it will saturate the separate materials. Water table affect roads in cutting, possibly of capillary action affecting the subgrade. In the cutting, subgrade will be saturated through capillary rise. So these are the requirement of highway drainage system. So we have to stop the infiltration through the pavement. So infiltration from the top of the bituminous materials, we have to stop huge dense bituminous peaks as surface course or PMC with seal coat or MSSS, huge micro surfacing with rubberized bitumen. So it will reduce the infiltration of water from the top of the pavement, sealing of cracks through slurry seal or fog seal developed in the pavement, a strengthening of pavement by another overlay, and provision of drainage blanket. These parameters we should apply to stop the infiltration of water from the top of the pavement. We have to provide surface drainage like proper camber of pavement and shoulders as per the standard.
साउंड ही नहीं आ रहा है इसमें। हेलो,
Hello,
ये इसमें मीटिंग की थी, इसमें डेस्कटॉप में जो है ना, साउंड नहीं आ रहा।
I am not able to hear. Please loudly you can speak.
म्यूट लिखा है इसमें ना, म्यूट तो है नहीं, हरा चल रहा है, म्यूट करना।
क्या सुनाई नहीं दे रही है?
इसमें बनाया सुनना
Are you able to hear my voice?
वेब रूट में एक ही बनानी
I am not able to hear your voice, what you are
नहीं
saying.
है इसमें अच्छा
I can continue?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. So surface drainage, we have to provide surface drainage like proper camber of the pavement and shoulders as per standard specifications. Longitudinal gradients should be provided, which may be about minimum 0.3%. Longitudinal side drains should have adequate weighted perimeter, grade, and lining. Similarly, for subsurface drainage, we have to provide provision of GSP of proper grading or sand blanket. It may be alternatively we can use geotextile, or we may provide deep trench with geotextile. Other measures we can apply for proper drainage system. Subgrade should be more than 1 meter above the highest flood level, or quality control to restrict air voids content to design value, use of anti-stripping agents. So typical camber provided for 2-lane road is given in this table. For earthen, gravel or WBM surface, we have to provide 3 to 5%. Thin open graded bituminous surfacing like this, we have to provide. For high type bituminous surfacing, we have to provide camber like this. On for cement concrete surfacing, we have to provide transverse truss structuring to 2.5%, and in case of longitudinal tin structure, 2.5 to
म्यूट कर दो अभी म्यूट कर दूं
So drainage on shoulders. Black top shoulders are durable and help in quick disposal of surface water from the pavement. For economizing cost of the construction, shoulders are generally constructed with subgrade soil even on highways in India, as surface water cannot flow freely on earthen surface, and camber is enhanced to 2.5 to 3% in normal construction. Silt and clay soil are generally susceptible to erosion because and there is a specification so for embankment slope, PI should be around 16 as per the IRC guidelines, and good muram or gravelly soil is relatively less prone to erosion. Longitudinal gradients should be provided along the pavement, so with a view to facilitate quick removal of rainwater. Longitudinal profile of the road normally is not designed flat. It should be 0.3%. When the road is provided with curbs, as in the case of urban scenario, flat surface can result in collection of large quantity of water on the road. To avoid this situation, a minimum longitudinal gradients of 0.3% is considered essential in most of the cases. Now we will discuss here different surface drainage. So surface drainage of pavement, including its adjoining areas, is an important aspect of pavement design. When a road is constructed on a natural terrain, the waterways are intercepted, and hence necessary measures have to be taken to divert such water from the pavement. Water on road surface received from rain and snowfall has to be disposed of as quickly as possible to keep the road surface dry from safety considerations. Normally, side ditches, line drains, catch drains, network of cross drainage structures are provided as a part of the overall surface drainage system. Surface drainage is accomplished by providing cross slope or camber to the pavement so that the runoff water can be cleared from the road surface quickly. Normally, a driver should prefer a flat and dry surface for provide driving, but some compromise has to be made between comfort and surface drainage requirement. The cross slope camber requirement differs for each pavement type. A mild cross slope is sufficient in dense surfaces like bituminous concrete surface or concrete pavement. Open graded bituminous surface and granular earthen surface requires relatively a steeper cross slope for facilitating rapid drainage. In previous slides, we have shown you table how much camber is provided. So depending upon the type of surface, we have to provide accordingly. Granular or earthen surface requires a steeper greater slope to avoid seepage of water to lower layers, but too much cross slope may promote erosion of surface. What is the factors which affect the surface drainage? So surface drainage, geometric feature of the pavement like longitudinal and transverse slopes, curves and gutters, outlets, type of surface, texture of pavement, texture of pavement come into the rigid pavement, median drains in divided carriages and lane widths. No research has been done in India on this crucial subject, except some work done by IIT Chennai. Considerable studies have been carried out in USA, both in laboratory as well as in the field also. Two types of drainage layers have been tried by advanced countries, free draining subbases and open graded subbases called permeable subbases. They have performed free draining subbases rather than open graded subbases because of its more durable, more stable nature, having permeability in between 15 to 15 meter per day in laboratory tests. The open graded subbase having permeability 150 to 3150 15 meter per day has high degree of weight and has lower structural stability. Such materials was said to have resulted in layer where it was like paving on marbles. Based on these considerations, the grading of the drainage layer having permeability in between 15 to 45 meter per day is best suited for drainage layer.
To Mars white cover, right?
sir.
Another one is the alternatively for GSP layers, we can provide drainage composite layer, which consists of geonet between two geosynthetic layers. So this is the alternative of GSP layers where composite drainage system may be.
Final quarterly maintenance 16.
So these are the another drainage GSP layers, and this is the filter layer. Another one is connected with the line drain. This is the cross section of road showing drainage layer terminated at pavement edge in a flexible pavements. This is the flexible pavement and terminated like this. This is the perforated pipe wrapped with geotextile and water percolated to in this way and coming like this. This is the another view of the
नहीं सही क्या
moisture
होगा
movement,
वो एक्सेप्ट करने के लिए
the pavement. This is the common problem, depressed shoulders, wrong cross slope, insufficient camber of shoulders, which looks like this. Depressed shoulder, if you will see here, shoulder is like this. If it is like this, then water will be percolated like here. So this is the longitudinal gradients should be provided 0.3 minimum, and these are the already we have shown in the depending upon the type of surface. These are the depending on the rainfall area, camber of the surface should be provided like this.
Except for
This is the cross-sectional view of the roadside drains. In a rectangular drain, and this is the trapezoidal drain. Another view of the triangular drain. This is the dimension of the a particular surface drain, and this is the angle drain, and this is the curve and channel drain. This is the semicircular drain. This is the saucer drain. Another view of the in hilly slope catch water drain. We provided here also in both sides in hilly terrain. This is the culverts like this. This is the causeways, two type of causeways, low level causeways and high level causeways.
इसमें
Section of that.
कितनी
And
फाइलें
now
हैं?
we discuss here surface drainage.
स्टार्टिंग नहीं चाहिए, जो बाद में हुए वो वाला निकालो लास्ट.
The water received on surface of pavement, medians and shoulders also shifts to lower layer through permeable
स्टार्टिंग से है, ये इसको मत
cracks,
खोलो.
potholes, joints, which needs to be got rid of for the durability of the pavement. Such moisture in the base and surface of pavement is extremely harmful and often leads to settlement of the distress. So now we will discuss here. So subsurface drainage is an important of as surface drainage for long life and better performance of the pavement. Moisture which reaches lower layer of the pavement from all sources. Ingress of moisture from the pavement surface, seepage, and capillary rise of groundwater is termed as subsurface drainage. So for subsurface moisture, two type of water will be considered. One from the top of the top water coming into the pavement, and another one is water coming from the capillary rise. So disposal of this moisture is termed as subsurface drainage. So consequences of lack of effective subsurface drainage system results in premature failure of the pavement with formation of cracks, settlement, rutting, foggy action in the case of flexible pavement, and crack and fragmentation of cement concrete slabs. These are the various sources of water for subsurface from the cracks, holes formed on the pavement. Water can seep below the pavement layers. From the failed transverse and longitudinal joints in rigid pavements. From the longitudinal joints between pavement and shoulders, water may percolate into the below pavement layers. From the earth-filled shoulders and medians. From capillary saturation when water table is high. Seepage water from the adjoining higher ground in the cut section. So these leads to the subsurface drainage system. So provision of granule surface, cum drainage layer above subgrade helps in subsurface drainage. Leaking, seeping from top and arrest capillary water from the bottom. Drainage layer must be extended up to the embankment faces for the purpose of free flow of the subsurface water So granular subbase layer should be provided as a subbase subsurface drainage. It should be intermediate layer between subgrade and granular subbase pores. Essentially, it should be a drainage or a filter layer, which it also distribute the stresses imposed by the traffic or vehicle load. GSP materials should be like this. It may be locally available material, natural sand or gravel or crushed stone, or it may be from industry waste materials like concrete, crushed slag, crushed concrete, or brick metal. So these are the gradation of GSP layer. Another one is layers. Another one is also layers as per IRC guidelines. These are the MRT specifications. So what will be the properties of GSP materials? Water absorption should be maximum, it should be less than 2%, and LLPI, LL should be 25%, or for rural roads, PI should be less than 6, and should satisfy the CBR requirements 98% of laboratory dye density, and loss abrasion value should be less than 40. Used especially when WBM is to be laid directly over subgrade. It acts as an inverted chalk. 25 mm screening type B or post grant increased to 100 mm when subgrade is fine or city clay. Primarily functions as a drainage layer. The sand layer spread needs to be flooded before 1 or 2 passage of the roller. So after applying this layer, we have to saturate these materials before rolling. So saturation means we have to flood these materials. After this is one of the typical sand layer which was used in the construction of a road at Dwarika sub-city in Delhi. So this is the after laying of sand layer as a GSP layer, it should be flood up before compaction. So these are the gradation which was used in the construction of internal road of Dwarika sub-city in New Delhi. So this is the proper subsurface drainage. This is the lined drain in both sides. Another view of the extended subsurface. This is the like this. This is the also another view of the subsurface drainage. Post sand filter, perforated PVC pipe wrapped with geotextile, and this is the granular material outside that, and it should be below the surface layer for drainage of surface water. This is another view of surface drain in valley cuts. This is the granular materials. This is the dimension of subsurface drains. To arrest the capillary rise. Actually, subsurface drainage provided for two type of water drainage. One is coming from the top, and another one is coming through the capillary rise. So in this way, through capillary rise, moisture will come and it will saturate this. In that situation, we have to provide granular materials. And another one is the proper subsurface. Moisture movement between verge and subgrade. Subsoil drain between the verge and carriageway, and provision of paved shoulders be provided. This is the seepage from high ground. If water is coming from high ground, high level to saturate the roadway, we have to provide like this. Another one, as a alternative of GSB layer, we have to provide fabric also to stop the capillary rise. So this is the proper example of that. This is the pavement, and water is coming from the ground through capillary rise. When there is no any fabrics or GSP layer is provided, then water will reach up to the pavement. When fabrics is provided, water will be terminated at this level only. So this is the deep surface come deep trench drain. And this is a typical view of drainage system, which was provided at nearby the Josimat area. Here, this is the details of cross-section of that. In uphill side, trench was made. And if you will see, this is the actual view of the touched trench drain and geotextile trap post aggregate materials. Another one is proper subsurface drainage, where perforated pipe is inserted in the slope and water is coming like this. Urban drainage system we will discuss here. So providing in modern city estates, curb and channel sections should be provided, gully chamber with RCC grating, RCC pipe drain and manholes should be provided. Like in this, we will see vertical curb separating footpath from the carriageway. You'll see like this. You have to provide water drained from sloping gutter to gully chambers. A spacing should be around 3 to 40 meters. Gully chambers have grating, steel or concrete. Water from gully chamber is laid into RCC pipe having independent gradient. So this is the grating frame of that. In that grating, this is the median. This is RCC pipe. This is RCC road grating. This is the cross section of that. XX cross section, YY cross section. Both are XS and YY cross section. And manholes should be provided for inspection, test, or cleaning the drain. A spacing of manhole should be provided from 10 to 20 mm circular, 1 mm diameter, or rectangular 1.2 into 0.9, or maybe a square. Fiber reinforced concrete cover also should be provided on that. This is the drainage of high embankments. So on the high embankment, we have to provide chute drain also. These are the protection of that on high embankment to stop the erosion due to surface runoff. Drainage of intersection. So large area needs to be drained off at the intersection. Stagnation of water would reduce the capacity of the junction. Complicated drainage due to presence of medians and directional islands. Non-urban locations, water lead to side drain. In large directional islands, water collected in a pit and drained by pipe raise the surface level of the intersection than the roads meeting it. So this is the drainage at intersection for two-lane divided carriageway. This is the drain. This is the drain provided at the intersection. This is the drain. On roundabouts, or we can say rotary, sharp curves flow of water towards central island. Provision of circular drain at the edge of central island. Water lead from the drain to a natural drain. So you'll see this is the rotary and this is the outlet, and drain around the rotary should be provided. At one leaded should be provided for outlet of that. Subway and underpass, road subway and railway crossings. Flow of water from sloping approaches and also from adjacent higher level roads. Provision of unmanned pump systems velocity of water pumped out to 0.8 to 1.2 mm per second. So in this subway and underpass, provision of unmanned pump is essentially required. It will start when water will be accumulated into the that there, and velocity of water should be like this. So in grade separated structure or on flyovers, provision of down deck pipes adjacent to piers and side of arrival should be provided. Discharge into manholes at the ground level roads connected to underground drainage systems. Longitudinal slope approaches should be 3%. Provision of 2-3 inlets at close spacing for effective proper drainage. So this will see like this. This is the drain system provided here for dissipation of water from the pavement. And now a typical example of airport drainage we will discuss, which is carried out by CSIR, CRRI, and it is implemented also. So apart from road drainage, for interesting purpose, I am going to present for a typical drainage system after failure of pavement was investigation was carried out by CRRI and at Calicut airport, and some investigation was carried out, and then proper planning and execution was carried out by the Airports Authority of India. So we will see in airport drainage system, there are two sides. One is land side, which is called parking lot, public transportation, and access of road. And another one side is air side, which is access to aircraft or runway, taxiway, and ramp. So for proper airport drainage system, requirement is not only to dissipate the water. Here, safety of aircraft is essentially we have to consider service life of the pavement and formation of puddles on pavement surface, which may lead hazardous during taking off and landing of the aircraft. So what will be the purpose? For intercepting and diverging of surface as well as groundwater, or we can say subsurface water flow from the lands adjacent to airport. Removal of surface runoff from the airport and removal of subsurface flow from the airport. So both type of water flow, surface runoff and subsurface flow, we have to dissipate from the airport pavement. So design of surface runoff should be carried out, estimating the runoff based on probability of occurrence of a storm water once in a 5 years. We have to use this equation, and we have to estimate this. So here, these are the parameters which was adopted at Calicut Airport. A diameter of the perforated circular pipe is about 150 mm, and laying of slope of pipe 0.15%, and pipe should be surrounded with filter media, and thickness of filter materials should be more than 150 mm, and permeability of the filter material should be more than surrounding soil, and manhole should be installed at 300 meter, and riser should be provided in between manholes. So this specification was implemented at the Calicut airport. So a storm water for surface drainage, a storm water collected from the discharge area through inlets. Inlets is concrete box covered with grating made of cast iron or reinforced concrete, which may take aircraft hill loads. Cross center to center distance of inlet was 100 meter. Location of drain, edge of runway pavement, or toe of the sloped area. Grading of storm drain 2.5 feet per second for self-cleaning, and design entire runoff should be drained in 1 to 2 hours. So these parameters were considered during the design of drainage system. Catch drain for ponding facility, catch basins to reduce the diameter of drains, and ponding for sometimes connected to storm drains. Surface drainage, remove water from the base course, remove water from the subgrade beneath a pavement layer, and intercept and collect, remove water flowing from spring and previous strata. Base drainage, where frost action occurs in the subgrade beneath a pavement, where the ground water is expected to rise to the level of base course, where the pavement is subjected to frequent inundation and the subgrading is highly impervious, and subsurface waters from adjacent areas are seeping towards the airport pavement. These are the methods adopted for subsurface water. Base course are usually drained by installing subsurface drains adjacent to and parallel to the edge of pavement. Previous material in the trench should be extended to bottom of the base course. Center line of the drain pipe should be placed a minimum of 1 feet below the bottom of the base course. Subgrade is drained by pipes installed along the edge of the pavement, and center line of the drain should be placed at the edge. This is the pictorial view of the proposed drain. This is the pavement, the base course, subgrade groundwater table after drainage. This is the 6-inch. Now, this is the typical photographs of the airport, view of the embankments, existing embankments near the airport. Actually, here this airport is on base constructed on a hillock of the on the hillock, and this is the view of the existing embankments, and oozing of water on the airport pavement was there. So water is trapped into the pavement. A stagnant. This is the at one location a stagnant of water on the surface of our runway. This is the close view of already revealed or a stripped a stripping of aggregate on the surface of the runway. This is the, you see water is oozing on the runway. Cracks are already there. See revealing cracking on the turning pad of the aircraft area, and this is the pumping failure of at the turning pad of the aircraft. So, what was the causes? So, camber disturbed due to frequent maintenance. Actually, this runway was not properly working due to cracks, all those things. So, frequent maintenance was carried out at in patches position. So camber is already disturbed due to frequent maintenance in part wise. So improper surface and subsurface was observed. Weakening of subgrade layer also. Reduced bonding between bituminous and granular layers. A stripping of pavement which ingress the water through the cracks or porous structures was observed. So, through proper investigation, three test pits observation was carried out, two at location on turning pads, one along the runway, and size of the pit was 1 meter by 1 meter, and it was prepared up to the subgrade level from the top of the surface of top of the runway to the subgrade level, and heavy amount of water entrapped in subgrade granular material and bituminous surface was observed. After making pit in up to the subgrade level, in all three pits, we have observed that water is already entrapped in the granular and bituminous surface, and water stagnated at subgrade level. Water is not moving at all, and collection of subgrade sample was carried out. So collection of embankment soil from the slope was also carried out, and it was found that embankment materials is like GC, and subgrade material is sandy clay and gravelly clay. Liquid limit was more than 35, plasticity index was more than 20, and permeability like this, and compression index like this, and cohesion and phi value is 22 kPa, and angle of internal friction is 30 degrees. So a stability analysis of the embankments was carried out, with height of the embankment was 45 meter, slope is 1.5 to 1, 1.5 horizontal, 1 vertical. Surcharge load was carried out at 20 embankment and pavement 20, and traffic loads 56. Earthquake coefficient was considered based on earthquake zone of Calicut area, and factor of safety was considered 1.2 was obtained, which we can say slope of the embankment was stable. And settlement analysis was also carried out, and total settlement was observed 230 mm, and year of construction was 99. Considering that, we can say already 80% consolidation is completed. So embankment settlement has no effect on distress of runway or turning pad. So this concluded that there is no any effect of settlement uh, on the distress of runway or failure of pavement of runway. So what these are the recommendations was carried out. A need of the efficient surface and subsurface drainage. Surface drainage minimum camber should be provided 1.5% to dissipate the water, and subsurface drainage transverse drain within the shoulder should be provided. Longitudinal drains collect water from the transverse drains at edge of the shoulders throughout the drain length of the runway should be provided, and interceptor drains carries the subsurface water to open drains. So these will be shown in the second later on slide, where is transfer drains, where is longitudinal drains, and where is interceptor drains. So you will see this is the close whole drainage system recommendation. So you will see this is the center portion is the runway, and along the parallel to the runway, at interval of this one was provided the interval of that is around 45 meter. Center to center distance of intercepting drain is 45, and intercepting drain is connected with both side open drains. Open drains, and this is the elevation of the whole runway. This is the runway, and proposed camber was 1.5%, and this is the transverse drain, and then this one longitudinal drains, and this is the intercepting drains. Intercepting drains is connected with open channel of both sides of the runway. And this is the cross-sectional details of transverse drain. This is the cross-sectional details of longitudinal drains. And this is the intercepting drains. Coarse grain materials are wrapped with geotextile. Our dimension of this is given like this. For all, dimension is given like this. So this is the laying of longitudinal drains, excavation by the equipment. And now see this T junction for longitudinal and intercepting drains. This is the HDP pipe, and now this is the laying of geotextile, in which perforated wrapped with geotextile will be kept into this, and this is the pictorial view of that. This is the joint section. This is the lead HDP pipe wrapped with geotextile. This is the T junction. And now in this longitudinal drains, aggregate materials with proper gradation was loosely filled in this. This is this one. This is the after filling of the trench with granular material and HDP perforated pipe. This is the runway, and parallel to the runway, longitudinal drains was provided, and then here transverse drain was provided. Now we can conclude the presentation. Well-designed drainage system will be very economical maintenance cost, and it should be taken into the mind before a design of the road pavement. So now I am going to conclude the presentation. Thank you.
सर ब्रेक कर ले 15 मिनट का सर
Okay.
सर ब्रेक कर ले 15 मिनट का
No, now it is my presentation is over.
It's over.
Over.
1 minute
My-
sir. Okay, 1 minute sir.
For today, if the participants have any questions or query, please ask your questions. Participants are again requested, if they have any questions or any doubts, please ask your questions or clear your doubts with our faculty, sir. I think there is no more questions from the participants side, so we can conclude this session for this lecture session. So I will give you thank you very much to Dr. A.K. Sinha sir to present his presentation and share his experience among the participants.
Thank you, Sunil. Thank you, Sunil.
Okay, and actually, we have already informed to the participant that today is the last day of this training program. So this will also be a concluding session. I have already shared the Google feedback form on the WhatsApp group. In that, participant can give their feedback by clicking on that link by today evening. Your feedback is very important for us to design a next training program on the same topic. So all are requested to give sincerely your feedback and give the details which are required to be modified or to be changed in our schedule so that we may prepare our next schedule for the next training program. If any specific participant want to share with us regarding the feedback of the training program or regarding the contents that covered by each of the faculty during these 6 days of the training program, all are welcomed. Sinha sir, you may left here. There is no problem, side.
Okay, thank you, Sunil. Thank you, Sunil.
Yes. If any participant want to share any specific feedback on this session, please share your feedback. However, we are taking the feedback from all the participants on that Google form also. So, any participant want to say something, he can tell us about the training program or any contents of the training program, what are to be included, what are to be deleted, any specific. If the participant wants, please tell us. He is free. We will appreciate the recommendation of the participant also. Any participant want to say something, he can tell us. And we will also issue the we will also issue the certificate in 15 days time. Who have secured their attendance more than 75%, we will issue certificate to those only. But certificate, I think, will be in position to issue in 15 days time. Okay. Any participant want to say? Otherwise, we can conclude this training program here.
Hello,
Yeah, please.
sir. Regarding this training, I want to say something, sir. Hello, sir. It is audible.
Sir, your voice is not loudly. So,
Hello.
yeah, please tell loudly. Actually, we are not received your voice clearly.
Hello.
Yeah, please.
Sir. At the outset, I would like to convey my heartiest thanks to eminent faculties for their elegant and excellent PowerPoint presentation with a deliberation in descriptive, easy, simple language on different subjects, sir. Sir, water being the main enemy of our road and highways, thus drainage system is the most important part of our road construction. Sir, after attending this training program, what we found, the design and proposal of drainage system by DPR consultants seems to be without proper study of geological, hydrological study of the project site, etc. But
Yeah.
it is just, sir, it is a conventional matter. Whereas the maximum of our problem is unique and deeper from the place to place. At last, sir, not the least, Once again, I have heartiest thanks to all the eminent faculties for interaction, solution, clarification, and especially heartiest thanks to Sanjay sir, Sunil sir, Neeraj and his team for taking so much of pain for organizing and conducting such type of training. With a request to Sir IHC for
Yeah,
recommending to the Sir MRTH, as
yeah,
now the MRTH has introduced CT GSV. They have made it a mandatory. In every project they must do some portion of the CT GSB. Exactly like that, sir. If it can be recommended to the MRTH, that
mhm,
at least, sir, what we have learned here regarding geogrid, textile, and other things, if it is also made a mandatory in all the project, so that no doubt, sir, it is only 2%, which can be increased to the some 3 or 4%. We'll be very
mhm.
thankful. Otherwise, sir, we used to learn, but we are unable to execute or just have a practical experience in the field. So once more, thank to all, sir. Thank you, sir.
Okay, okay. Thank you very much, Billy. We will discuss with the officials of the ministry as well as the expert faculty in this Indian Road Congress for the things which you have shared with us. Okay. Uh, any other participant want to say something?
Sir, what should be done if there is no space for side drainage and especially in city areas?
Yeah, Tanvir, your voice is not audible.
I'm saying that what should be done if there is no space for providing longitudinal drainage along the main carriageway, especially along city areas. What should be the remedy for that?
Your question will be shared with the concerned faculty and we will try to take the answer of the question and then we will share you. Okay?
Okay, thank you.
Yeah. Actually, this is the concluding session. In that, I want to only focus on the feedback of this training program. If any participant has any question, please write your question on the WhatsApp group. We will share your question with the concerned faculty and try to get the answer of all of your question. And we will also provide you the answer on the same group also. Okay. If there is no feedback, so I will request to the participant by today evening, please give the feedback on the online mode of this Google form. So your feedback is very important for us. We will also issue the certificate within 15 minutes time. Okay, and we also appreciate all the participants that they taken out their times to attending this training program, and I think that this training program will be very beneficial for all of you. So now these words I conclude this uh, training program, and so thank you very much for the participant as well as Sri Neeraj Das, who every day start the training program and finish the meeting every day, and he was also attending from 9:30 to 1 o'clock every day. So thank you very much. So now we are concluding this session. So Neeraj ji, please finish the meeting.
जी सर